Hello and welcome to another edition of DAX.Tips. Today I'm going to be showing you how you can visualize your Power BI refresh so you can get a better understanding about which items inside a refresh are slow and which ones are fast. The idea here is that you can use this information to potentially make your refresh much faster when you know which objects are taking a long time to refresh. And here's a look at the finished result. So to show you how you can get to this, I'm going to switch over to an example Power BI model here. So I have a model with no visuals with a bunch of tables, and included in here I have an Excel table. So most of these files come from an Azure SQL DB, but I do have an Excel table in here to just see how that performs. Now what I need to do is start SMS SQL Profiler. So SQL Server Management Studio is a free download. There's a link in my blog. Go and grab it and install it. I also have a link in my blog that explains how you can set this up as an external tool. Now this just saves you a bit of time finding the correct connection string for Profiler to talk back to this model. And here we go, I have got the icon here called Profiler in my external tools. So I'm going to click on that to begin that. And I'm going to start a new trace. I'm going to use the blank template, and I'm going to jump across to my Events Selection tab, where I can go down and hopefully you see the job graph event and just click on the leftmost checkbox. That'll automatically click all the remaining boxes. And then the other item that you need to check is this progress report end. Now this is the most important one. You can do without job graph. It just helps with a little bonus piece of information when you're doing concurrency work, but let's just make sure that we have the progress report end event checked. So we have just 2 events checked, and we're going to run this trace. And there are no events in the window. I can jump back to my Power BI desktop file and just kick off a refresh. I'll minimize this so that we can see the profiler in the background, and I'll click the refresh button. Now this is going to go and spend some time thinking about how it's going to connect with each of the various data sources in this model. I only have 2. And we can see here it's just about to probably kick in and start firing queries. And here we go. So you can see we have activity in the Power BI desktop dialog, and in the background we can see a bunch of events taking place. And this will just take about a minute, I guess, to complete. The fact product inventory table in this model is the largest. It has about 700,000 rows. So pretty sure once this is complete, we'll be done. 500,000, 600,000, it's not too bad. This is not a localhost database. This database is from Azure. So there we go. And I know that it's complete because it has a couple of job graph events at the end. There can be more than 2, depending on how complex your model operation is. This will page over multiple events. So we can pause or stop that. And the idea now is we can save this report as a trace XML file. This is one of the really important things you need to understand and follow. Don't save it as a trace file, save it as a trace XML file, and we'll save it somewhere locally on our machine. So we'll call this demo1.xml, and this is the file we're going to go and pick up and collect from our analyze my refresh report, which if I bring up now, we can go and find that. So this is looking at some other data. So let's just point to the XML file that we just captured and saved to our local machine. So I'm going to go into my transform data page to fire up Power Query, which is hopefully opened on a different screen. I'll just resize that, drag it across, maximize that for us so that we can see. And we just need to update this one parameter here. I save the file into I think it's called demo1.xml, and it looks like that's working. Let's close and apply. Now this refresh, we're not analyzing, this is just importing the XML file we saved from the trace. And the Power Query here does some interesting transformation around pivoting some of the data and taking the XML, parsing the XML file into something useful that Power BI can analyze. And here we go, here's the finished result. So what we can see there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 objects that were refreshed. The total time was 33 seconds. The slowest item in this case, running from Power BI Desktop, was fact product inventory, which began here at this point in time, and it completed over here. The blue area denotes, the start of the blue area is from when the Power Query fired the request to the data source. Now, even though it says execute SQL, it's not necessarily an SQL operation that we fire to the data source. You know, Excel we don't send SQL to, but we send a request to say, hey, we need some data. And in the case of a SQL table, the blue bar finishes at the point where the first row is being delivered back from the data source. So this is how long the query took to think and start delivering data back. And then the yellow bar is streaming the data out. And that's the analysis services database inside Power BI, analyzing it, encoding it, compressing it, and squashing it into the database before finally setting the database to read only. Now we might think that product inventory is the worst table here, and it's the one that we need to optimize and make better. But if we have a look at the information below the Gantt chart, we can see that the fact product inventory table had 776,000 records, which took just 32 seconds to process. So it was running through at 24,000 records per second, which is actually quite slow. This probably says more about my broadband connection than anything. So it's probably not the table that is going to cause problems, especially once this is up in the service. Let's have a look at the other end of the scale here, because we're sorted by rows per second. With Excel, we took 10 seconds to read 4 rows, so 0.4 of a second per row. That's not very efficient. Product category, we took 7 seconds. I mean, it looks like there was a point where the fastest query was going to take this long. So what I would like to see is how this report behaves once it's published up into the web service. Another really important thing I want to highlight is that in Power BI Desktop, all of these objects will begin processing at exactly the same time. It doesn't try and limit the number of parallel operations that will take place. When this model gets published to the service, there are some things that kick in and might restrict it to only 3 objects at a time or 6 objects at a time that you can influence, but it's not until you visualize this that you really understand what's going on. But it's as easy as that. So that's how you can run a trace against Power BI Desktop to capture your information and look at that here. So now what I want to do is jump over to reports that are published in the web service. So I have a premium workspace. Now this could be premium per user, and I have 2 data sets in here. So I want to connect to this workspace, and more specifically to one of these 2 data sets in this workspace. Now to do that, first of all, I need the connection string for the workspace. So I go over to my settings, and on the premium tab down here, there is a connection string as such. So I'm going to copy that and go over to a fresh instance of SQL Profiler. I'm going to start a new trace. And here in the server name is where you paste in that text that we looked at. But a really important different step that you need to do when you're connecting to a model in the service is click Options, because we need to connect to one of those 2 databases. If you know the database in, you can just simply type it in here. Otherwise, you can cheat and say, let's just browse the server. And this is going to ask me to log in. And I'm about to get a notification on my phone to say, hey, are you who you say you are? And I'm looking at my phone, waiting for the authentication pop up. And in this case, it's that number, 76. And when this succeeds, it's going to present me with a small dialog showing me all the data sets that happen to be in that workspace. And I know ahead of time there are 2. So we're going to trace this one here, job graph NP, which stands for no partitions. We'll click on that, and we can now connect. When we connect to this database, we'll get the same dialog I showed you earlier when we were connecting to Power BI Desktop. So we're going to start with the blank template. I'm going to click on the event selection, expand job graph events, and I'm going to expand the progress report and click on the progress report end event. I'll zoom in so you can see those. So these guys here. Excellent. Now we can run the trace. Now we've got multiple ways we can kick off a refresh on the web service. Now, this will pause for a little while it's connecting, but while that's waiting, what I'm going to show you is how you can run a refresh in SQL Server Management Studio. So here, when I start SQL Server Management Studio, which is free, I can make an XMLA connection to that same workspace. I don't have to go through the, I don't have to specify the options. That's only needed for running this specific trace. And I'm now connected to this workspace, and I can paste in perhaps a little bit of JSON code. This is what we call TMSL, Tabular Modeling Scripting Language. And I can paste this in here, and when I'm ready, I can just hit the execute button. And what this is going to do, I'll need to point it to the right database that we're tracing, is it's going to run a refresh. It's going to do a full refresh on all of the objects in here. Now you can extend this and make this quite flexible to pick and choose individual tables, individual partitions inside individual tables, so it gives you much more fine-grained control over what you want to refresh when it comes time to refresh. So let's just check to see if our profiler is ready to start seeing events, and it appears to be. So if I come back to my SSMS and reduce the size of it so we can see the profiler in the background and click the execute button, effectively what I'm doing is outside the web portal, I'm requesting a refresh. And there's a whole bunch of interesting activity here telling you what's going on. The profiler is capturing the events that we care about. And when this completes, we should see at the bottom that the command completed successfully. And at that point, we can pause or stop the trace, save the trace XML file locally, and repeat what we did earlier. We'll bring that into our analyze in our Power BI report. Now, one thing that I haven't checked just before this video is when you do kick off refreshes like this, it may not appear in the web portal. Whereas obviously any refresh that you initiate via the web portal will appear in the refresh history. So just be aware of that possibility. Okay, so this is finished now. So we can hit pause, and I can click File, Save As, Trace XML file. We'll call this Demo 2, which is just saved to a local folder in my hard drive. I can go back to my Analyze in Excel report, transform the data, edit the parameter. I might not necessarily need to do this. I can probably just type this in without having to fire up the Power Query editor. But let's just close and apply. We'll get the usual dialogues about pending changes. Let's apply those changes. It's reading in this small file, and it is a relatively small file. And what that's going to tell us is how long did the query take to run? 35 seconds. Pretty good. I didn't have as many tables in this model, but here you can see the slowest object of all the refresh objects was here, this Excel table. It started at the same time as the others, and it ran for 34 seconds. And that's a query speed of 0.1 of a second. That's pretty slow. Whereas my fact internet sales was running at about 15,000 rows per second. Not too bad. Now the number of columns, the number of string columns, there's a bunch of things that can influence this, but typically the more columns you have for the same number of rows, the slower, or the more time analysis services needs to compress encode and save the data. So here we go. We've got a pretty good obvious starting point. And in this case, what I could do is either remove the Excel table completely from my model. It's only 4 rows. Perhaps I could just hard code those in, or I could move the data across to SQL, or I could maybe use a data flow. And Matthew Roach has got some wonderful articles on all about data flows and how they might be able to help. Now, the other thing I want to highlight is down here at the bottom, where there's a second tab called Using Slot Data. And in this case, we were able to use 7 slots. But what you can do in SSMS, and we will do this sometimes for you, imagine you had 20 objects that needed to be refreshed. It will only ever refresh a certain number of objects at a time. And we can control that in SSMS by doing something like wrapping the refresh TMSL in a sequence, and we could set the max parallelism to perhaps 3. And I'll take this change, pop it into my XML that's connected. Yep. Paste that in. I'll go and make sure my profiler is running because I paused that. Now I can either clear out these events or I can leave it running. The Power BI file will support multiple refreshes in the same file. It should do. And there's a drop-down box in the top left-hand corner that allows you to either show all at once or jump between the two. So because this is unpausing, it's just connecting again. This is currently a little slow for the initial connection to get running again inside Power BI. But I will show you that drop-down box here. So when there are multiple refreshes, they will appear here with the genuine, unique ID. And you'll notice that a lot of these tables have this string of text after the name that you're probably used to seeing inside the model to help force them to be unique inside the model. So let's just check Profiler again. It's nearly there. And please let me know, give me some feedback if you do find this helpful, useful. Even if you find a bug and you capture a trace that doesn't quite work, I'd like to get hold of the trace, fix the EM so that it is more robust for more scenarios to make it more useful for other people. So what I'm going to do is clear the events out. This trace is running. I'll jump back to SSMS, make this a little larger so we can see the full script. And I'm going to execute this, but now I'm executing with max parallelism set to 3. And this refresh should in fact be slower. And you would expect it to. But however, the max parallelism value can be quite counterintuitive. Often when you increase this, if you have the ability to increase this, it doesn't necessarily mean you get a faster refresh. It can result in a slower refresh depending on the data source and how it allocates resource when the initial queries fire. I had an instance where I was playing with a Azure Analysis Services model, and I had 200 objects, and I set max parallelism to 40 as opposed to 20, and the one with 40 ran slower. Even though the data source and AES could cope, what was happening was the data source was allocating a very small amount of resource to each query, and long-running ones meant that they just stuck out at the end and were very slow. So I've just refreshed the wrong model. Let's execute this with the right model. And here we go. We can see the events firing in the background. The initial refresh took 35 seconds, so we're trying to beat that. I suspect we won't, because we have this long Excel file, and we'll analyze that a little bit too when that completes. Because max parallelism probably won't make each individual object faster or slower. It just restricts how many we can run at any particular point in time. And we're coming in at about 37 seconds, 39 seconds. That's not too bad. We'll pause that and we will say File, Save As, Trace XML file. And we'll call this Demo 3. Go back to my Analyze. If we go Edit Parameters and type in 3 here. Hey, I'm learning on the fly. Let's apply changes. And these examples of these XML files are pretty small. And here comes the data. Cool. So remember, we're on the second page using slot data. Because I restricted the number of parallel operations to be 3, you'll see here that in the second slot, this object here, which I should probably put the object name in the tooltips. Let's do that while we're on the fly. Object table name, probably progress report Let's extend that. Click on here. Tooltips. What might it be called? Object name. That's a pretty good clue. Let's put the object name in the tooltip. So we can see here, the dim customer took 1 second to run the SQL and a second to process it. And then when it completed, it went to dim date. And then it did fact internet sales all the way on to the end. And over here and above it, we have product category, subcategory first, then product category, etc. And as one finishes, the next one starts. And overall, it actually thought it took 34 seconds, so it probably rips out a little bit of overhead. So we potentially sped this up by 1 second, although that's a bit of noise, statistical variation, by limiting it to running only 3. But the main thing is we still have this very long this long Excel table. So messing with the max parallelism with this model probably isn't going to do terribly much. I think the focus to improve the refresh for this item is, as I suggested earlier, focus on ways that we can shorten this Excel file by moving the data into another data source or turning it into a data flow or something else. Now the last thing I just want to highlight is when you do have a long operation on a fact table that comes from a data source that can support queries such as SQL, as you can convert the large tables down into partitions, which will run parallel. And I think I'll save that for a different video in a future blog, because we're already at 22 minutes, and hopefully this has been helpful to see the visual walkthrough step by step. But please shout out if you've got any feedback, any questions, if you find any bugs, and I'll save this file over my last one. So if you re-download, you'll get the object name in the slot data, or you can just add that as I show to you. So thank you very much, and look out for more videos in future. Bye-bye.